All right, it's 2 o'clock. Let's get started. Good afternoon, everyone. This is Tej Tenmacham. For those of you who are not familiar with who I'm Tej Tenmacham. I'm a senior platform architect at Pivotal, dedicated to Cognizant from the Partner Alliance team. Today, we are going to talk about Pivotal Application Service. So when I do this session, right, so most of the attendees that attend this session are fairly new to Pivotal. So the agenda I start with is that I give a quick introduction to Pivotal, and then for the Pivotal application service itself, what I do is I whiteboard the platform itself, the key components within the Pivotal application service, and then I follow it up with a demo. And then end it with a summary. Typically, these sessions I have 1 hour. So one hour I do it for PKS and 1 hour on PKS. So we are for today stand and deliver. I'll try to finish it in 30 minutes. So you might find it to be like I might be rushing a bit because of the time. Some facts, right? So Pivotal was formed in 2013 as a spin-out from EMC VMware. Our chief executive officer is Rob Mee. We have over 2,200 employees in 20 locations globally. We went public on April 20th of 2018. At Pivotal, right? So our mission is to transform how the world builds software. And we help our customers achieve that mission through a combination, right, of a process and a culture, as well as a tools and a platform. Let me find a pointer. So Pivotal Labs, right? So Pivotal Labs is our consulting organization, which is almost 30 years. If you could mute yourself, please. Pivotal Labs is our consulting organization, which is 30 years in the making. Pivotal Labs pioneered the agile software development practices through working in small teams, paid programming, and iterating versus the, I mean, this is like 30 years ago, right? So everyone else was doing waterfall methodology. And Pivotal Labs, I mean, we were iterating and we were having small teams, and we were doing paid programming. So not only that, Pivotal Labs, right? So we also provide this tools and framework. So we do provide tools such as CI/CD tools such as Concourse, and frameworks such as Spring and Tracker. So these tools which help you, again, I mean, in the process and culture, as well as for you to write a clean and consistent code that you can actually change rapidly. So that's labs, and that's tools. And then the key component, right, the platform as a service offering, and that's the focus of today's discussion. So the Pivotal Cloud Foundry, which is a platform as a service offering, and I'm going to talk about more about that. So this platform, what it does is it lets you push your code to production, right, really quickly, and then you can iterate and then push again and again, so that as an organization, I mean, you can learn, and then you can iterate and then adapt. Let's jump into the Pivotal Cloud Foundry itself. So back until February of this year, Pivotal Cloud Foundry only consisted of one product, that was a Pivotal Application Service. But then starting February of this year, we have another product called Pivotal Container Service, which is our Kubernetes as a service offering. So now, like, Pivotal Cloud Foundry is an umbrella of products. For today, I mean, these are the two products that are under that are GA now, but in future we will be having a Pivotal Function Service as well. But today's focus, as I said, is Pivotal Application Service. And tomorrow we will talk about Pivotal Container Service. Most of the time I get asked which workload, I mean, which one should I choose? And most of the time it is not the question of one of these, right? Like, it's not an or discussion, but it is an and discussion. So typically if you sit with your customer on a discovery session, right, you sit with their application portfolio of products. So tomorrow, what I will do is I will cover a methodology that we use, kind of gives you a framework where you can actually decide, okay, this application is a right fit for a PAS offering, and then some applications will be a right fit for PKS, and we will look into that tomorrow. So let's jump into Pivotal Application Service, right? So this slide deck, I will come back to this. I can better explain this in a whiteboard. So let's jump into the whiteboard itself. So, so this is a Pivotal Application Service, and as you can see, there are two personas, developer and an operator persona, right? So let's start with the developer, right? So at the heart of the kind of, I mean, the Pivotal Application Service itself is that it knows how to run your application really well. So from a developer's point of view, right? So PAS is all about applications. So a developer, what he does is he starts with a framework or a language of their choice, right? So Cloud Foundry is supports multiple languages. So the code could be, it could be a Java application, it could be a .NET application, it could be a Go or Node, any of those applications, right? So let's, for this whiteboard, let's assume that you are building a Java application. So typically the flow is that, so you have your developer, he's building a Java application, and what he does is, so the next stage is that he checks in that source code into a repository. This could be a Git repository. So typically if you are building a cloud native application, right? So the key CI/CD concept is that you use a tool such as Concourse or Jenkins, which are like CI/CD tools. What you do is you use those tools from the source code, you build that application, and the output of that build cycle is typically, if it is a Java application, it will be a var or a jar file. So once you have that jar or var file, so what you do is that's where Cloud Foundry comes into the picture. Typically you can use a CI/CD tool to push the application, or you could download a CLI tool. So what you can do is there is one command called CF push, Cloud Foundry push. When you do that, right? So when you push an application, it goes through a process called a staging process. So the staging process, right? So the staging process itself has three key components. And I have explained that better down here. So one of those components is a build pack. So what is a build pack, right? So a build pack itself, so what in this example, I have pushed a Java application and a jar file, right? So the moment I do that, right, so it goes and so the build cycle itself, the build pack cycle, it has 4 different scripts that it runs. So the first script that it runs is a detect script. So a detect script, what it does is, so okay, now like it detects that, okay, it's a jar file. So it detects that it needs a Java build pack. Had it been a .NET application, it would get a .NET build pack. So the output of this detector would be a 0 if it matches it. So then what it does is it goes to the next script where the supply script, right? So what it does is in our case it is a jar file. So it detects that, okay, it needs a Java build pack, and then it needs a servlet container, right? So the build pack itself provides you a servlet container. So the application and middleware together, and then the next set of scripts, right? The finalize and release scripts. What they do is the finalize script prepares the app for launch, and the release script provides you the needed environment variables and execution metadata. So the output of this whole build pack cycle is a Cloud Foundry droplet. So once you have the droplet, right? So as I said, like the staging process has 3 key components. So after a build pack, you get a droplet, and then the platform actually provides you a file system as well as a hardened operating system. So that is a stem cell, that we call that as a stem cell. So the stem cell is an operating system. It provides you the kernel and devices, right? So This is hardened stem cell. So what happens is that after this whole staging process, right, these 3 stages, the output is a Cloud Foundry container. So that's a container. So all I had to do was push an application, and then it got the build pack that it needs, and then it created a file system and a stem cell and a container. So your application now, like had I said that I need only 1 container, so it would start with 1 container. But then, I mean, the platform is highly scalable, so you can actually click 1 click or run 1 command and scale it to multiple containers. So a container in the Cloud Foundry world, we call it as an application instance, AI. So these containers are, I mean, the name of the container that we create is called a garden container. And I frequently I get asked whether this is a Docker container, and that's not the case. So all whether it is a Docker container or a Rocket or a Garden container, they all follow the same open container initiative methodologies. So the same CNAMEs, namespaces, the same concepts exist there. So the container is created for you, right? So once the container itself is created, right? So what it does is you need so if you have multiple containers, you need a load balancing routing mechanism, right? So the platform itself has a pretty expansive routing layer. What it does is, it binds a route to your application, so I can actually access my application using that URL. So that's my container. So now, like, let's jump into, so where is this container running, right? So this container itself runs on top of a virtual machine. So this is the IaaS control plane. Cloud Foundry is a multi-cloud platform. So it supports, you can run PCF on any of the cloud vendors out there, AWS, Azure, GCP, or on-prem on vSphere. So the way the operator interacts with the Cloud Foundry is that, what he does is, there is a tile that he downloads from a Pivotal network. It's an ops manager. So what he does is he uses Ops Manager to provision Bosch, which is an orchestrator for the platform. What it does is it uses something called CPI. So what the CPI is, if I go to the next slide, right? So a CPI so each of the control, like IaaS vendors out there, they expose their IaaS control planes through a set of APIs. So this cloud CPI uses this create VM, delete VM, and so on to actually provision this all of these VMs that are needed for the platform itself. So the platform itself actually needs several components, right? So there are 15 or so components that made up of that make a Cloud Foundry. So you have a routing layer, you have an authentication layer, and so on and so forth, right? So all of these components, right? They run as a VM on the IaaS control plane. And all of these containers that we have created, that the platform has created, they run on top of a host VM. So that's kind of from an operator's point of view. So the platform itself, like if you think about it, right, like it will not be that useful had it not been able to, like your application might need some of this. Maybe you might need a MySQL or you need a data store, right? Or you want some of the for messaging you need an MQ, or for monitoring you want to configure an APM tool, and for credentials management a Cred Hub. So Cloud Foundry provides you an open service broker API through which you can subscribe to first-party services. First-party services are those that Pivotal provides, so such as MySQL, RabbitMQ, HealthWatch, and Cred Hub. Those are all first-party services. But then you can also subscribe to third-party services such as APM tools like New Relic or App Dynamics, or log analytics tools like Splunk or Papertrail, and so on and so forth. So Service Broker API is one of those. And then, so everything that I have talked about so far, right? So follows a methodology or a best practices. So when you are talking about building a cloud native applications, right? They follow this principles that was started by through a group of people within Heroku. These are certain rules and guidelines that need to be followed to be able to call yourself a cloud native application, right? So for today, I don't have time to cover all of these factors, but let's focus on one of the factors, right? Logs. So one of those factors is treat logs as event streams. And that's what we do here in the platform. So everything, right? So the application container itself will have logs, and the component VMs will have some of the events and metrics. All of this, what we do is we aggregate them through a log aggregator, and we have a concept called Firehose. So you can subscribe to services such as let's say you want an APM tool to monitor, right? So what we do is you subscribe to App Dynamics. So for example, so we get a nozzle for that for Firehose, and then App Dynamics will keep monitoring your entire infrastructure itself, the platform itself. So very powerful, right? So that's in terms of the architecture itself. It's already 16 minutes past, so let me jump into some other key factors, right? So when you call your application as a enterprise-ready application, right? So there are several components that make you an enterprise-ready application, but in my mind, the three key factors is that I mean SLAs. You will have SLAs such as 5 nines, 6 nines. And for that, I mean, you need a highly available application platform. So one of those factors is high availability, and the next factor is security, and then the third factor is that your applications and different environments should not have any configuration drift, and that's what the platform provides. So the way within Cloud Foundry, right, we provide high availability at 4 different layers. So the first layer, right, so when I created this container itself, right, so the container itself, like, so you will have a desired state. So within your manifest YAML, if I said that I need 3 containers, right, so if the application detects that one of the containers for whatever reason has gone down, then there are components, right, within the component VM, such as NSYNC and DDS and other components. What they do is they detect that this container has gone down, so immediately it will restart that container. So that's your first level of HA. And then the second level of high availability is that, so all of these component VMs, right? So this Go router might have a process that is running. So there is a monit process that runs on the agent, right? So the moment a process has gone down, it will restart it. So that's your second level of HA. And then the third level of HA, right? So all of these VMs, whether it is a component VM or a host VM, they all communicate through the agent. They have a heartbeat mechanism. So every 60 seconds, they send the status of the health. So if one goes down for whatever reason, right, so Bosch will restart it. So that's your third level of HA. And then the fourth level of HA, right? So as an operator, when he configures through Ops Manager, right, the platform itself, so all of this IaaS control planes, I mean, no matter which cloud vendor out there, they all have different regions, and within a region, they will have multiple data centers. So when an ops operator stands up your platform, right? So what he does is he actually configures the platform to be running on different availability zones. So if one zone goes down for whatever reason, right? So your application is still running. So that's 4 levels of HA. And then I want to quickly go to the security aspect. So I said that initially, right? So we provide this stem cells, which is a hardened operating system. So let's say if there is, I mean, I was looking at a meltdown inspector attacks, right? So when that happened this year, I looked at when was it out. The CVE was released on Jan 3rd of 2018. And by January 24th, there was a Bosch stem cell which addressed those CVEs. There was a new stem cell that was released. So within literally in 3 weeks, there was a new stem cell that addressed those issues. So what we do is, so we publish those stem cells, and then an operator can actually, so everything, right, like whether the container or the VMs, the component or host VMs, they all use this hardened stem cells, right? So they can use, the operator can actually patch the repair the entire platform with just one click and with zero downtime. So that's very powerful. So that's your, like, one, we call it as repair. We have 3 R's in security. So one is the repair. And then again, through Ops Manager and Bosch, to prevent this advanced persistent threats, right? So you can actually repave the servers, right? The VMs itself to a known good state. And you can do that, I mean, again, with zero downtime. That's repave. And then everything in the Cloud Foundry, right? So we have this Cred Hub that was released, that was GA actually last week. So what this Cred Hub does is, so when I subscribe to a service, right? So through environment variables, I pass the, when I bind an application to a service, the credentials get stored in a Cred Hub, the runtime Cred Hub. So the advantage of this is that, like, now, like, if I want to rotate the credentials, right? Like, I mean, I can easily do that, like, through one click and one command. I can actually rotate the credentials every few minutes or every few hours. So it's very powerful. So essentially, I mean, in a nutshell, right? So this is a total application service. So all I had to do was CF push an application, and the platform took care of everything, right? It created a container, it provided a runtime together, it provided a routing layer, it provided a high availability, right? It provided security, and so on. So so very powerful. So any questions on the whiteboard itself before I go to the demo?
Nope.
Right. Colin, you have a question?
I was saying nope.
Okay, great. So let's go ahead and quickly do a demo, right? So I want to build a RESTful web service that persists to a MySQL data store. So for this demo, so what I will be doing, I will use this Eclipse tool. So the easiest way to do that is, let me go to a Spring Starter project. So I'm going to use start.spring.io. I'm going to call this service as a REST web service demo. And I'm going to use, you can either use Gradle or Maven, so let's just use Gradle. Packaging the jar file, because I'm going to have a servlet container. And the language is Java, and the version is 8. Click Next. And then, so I'm creating a RESTful web service, right? So if I hover over that, right, so it tells me what it is. So this will provide me a full stack web development with Tomcat and Spring MVC. That's what I want for this. And then if I click on Actuator, right? So an Actuator does is, what it does is it provides me, so I want to be able to monitor and manage my application. So Actuator provides you that. And then I want to persist my data to a MySQL data store. So what I will use this Java Persistence API, Spring Data JPA, to do that. So those are the ones that I need to build a RESTful web service. And then I click on Finish. So within few seconds, and like literally in 30 seconds, I have a RESTful web service, a Spring Boot application that was created. So to save time, what I have done is I have already created four Java files. So a typical, what I have is a, so in this application, what I'm going to do is I'm going to pass my first name and last name. I want to persist that information to a database. And then when I do a get, I want to retrieve those from the database. So literally, I'm in 4 lines of code. So if you look at customer.java file, so I have my getters and setters here. So, and then if you look at my application.yaml, right? So I'm using the Spring JPA Hibernate to persist to a database. So I have my code, and then now I want to build, right? So let's use a Gradle to build. Okay, so REST Web Service, if I go here, go to build. So the first step is just first run a clean command to clean it, and then go to build So what it should, so literally in few seconds, so the build was successful. So now I have a build. So what happens is that, let me go to my, so here, so this is where I have my code. So the build file was there. So if I look at my manifest.yaml, right? So what I'm doing for my application there, so I'm saying that the name of the application is customer XYZ, and I'm telling the platform to pick a random route. I'm giving my memory and then the number of instances, the number of containers that I want to do. And I want my application to bind to a MySQL data store. So what happens is that if I do a CF push now, it should fail, because I mean, so that there is no service called MySQL right now. So what I have to do is I have to go to my platform and then create a new service. So creating a service is as simple as this, right? So you go to, so I want a MySQL data store. So click on MySQL, clear DB MySQL, Spark DB, select that. Let's call this as MySQL. So I have created that MySQL data source. So now if I do a CF push, right? So now it should go ahead and create that container. So when I run that command, right? So what's happening behind the scenes? So this is what it is doing right now. Let me go to my slide deck. So when I do that CF push, so what it does is it calls this cloud controller. And then the cloud controller, what it does is it sends this application bits are pushed to the Cloud Foundry blob store. And then whatever the resources that are needed, right? I said 1 gig of memory and then 1 container. So it goes to the Diego brain to request those resources. And then it goes through staging, and then your application should be created. So not only does it do that, like when I do the CF push, it also sets up a route. If I had enabled, right, like you can actually terminate your SSL. It also configures the health monitoring and so on and so forth. Binds your application to the backend service. So that's what it has to be. It will be doing right now. So it is right now pushing that application. So literally in a couple of minutes, it should be done. So right now it is waiting for the app to start. So let's look at that application. So let's see if I go to my apps, right? So customer -1 XYZ, that's right now it is creating. So what is so if I look at my environment variables, right? Like reveal my environment variables. So when I created that MySQL data store, when I bound my application to that, right? So it is passing this the username and credentials as a VCAP services JSON format, right? So that's what, like when I bind an application to that's what it is doing. And my customer XYZ, it is right. It is running right now. So if I click on that, I should get a white label error page. That's fine. So that means my application is running. To quickly test, right? So what I will do, I will use Postman. Let me copy this route. Go to that. Let's do a put, right? So that's my application. So what I will do, customer. In my body, I'm passing my first name and last name. So if I click on send, so I got a 200 OK. So that means that it has went ahead and created my my first and last name in the database. And then if I run a get, right? So let's change the route and click send. So I got the return results back. So I mean, this was as simple as that. Like literally in few minutes, I was able to push a production-ready application. I mean, everything is there, right? The platform takes care of everything. So very powerful. There are a few other things that I want to quickly demo. I think I might be like 10 minutes over, but let me try to finish it. Uh, so, so I have this application, right? So I was able to push that application and it's running. So I have this. I started with one instance, but if I want to scale it up, right? So I can quickly do that. So if I want to do it 2 instances, I can do that. If I can enable auto scaling. Once I have auto scaling, I can actually put some rules, right? Like based on whether it is a CPU-based utilization or whatever custom you want to do, you can do that. And one other thing is that, like, when I created that application, I chose to use Actuator, right? So now I should be able to configure my log levels. So I can, depending on the log itself, right? So if I want to just monitor the error and warning messages, I can do that. So besides that, right? So let me quickly show you one other thing. So I have another application called Articulate. For this application, right, again, this actually uses MySQL database to persist the data. So that is there. So let's say your application, now we have 2 versions of an application, right? So to do it in a highly available manner, right? So you want to test an application. So what I have done, I have two versions of the same application, Articulate version 1 and version 2. So here to simulate a blue-green deployment, right? So I'm going to start that. So initially it will start sending the traffic, application traffic to Articulate 1, and then some of that to Articulate version 2. So I can quickly, like, if I am comfortable with version 2, all I have to do is one command, unmap route, and then all of my traffic goes to version 2. So that's a blue-green deployment. And one other thing, right? Like, so one of the factors in a platform is that, like, you could subscribe to third-party services. So the logs that you are seeing here, the platform itself does not persist those logs. So what you can do is, what I have done, I have subscribed to a paper trail. Paper trail is, again, a third-party product which does this log analysis. So, so I have configured this log drain. So I have created a user provided service instance, and then so all of those logs that Articulate is sending, I can actually see that here, and I can do analysis here. So that's essentially the platform itself. Any questions on the demo before I jump to the summary? All right, if there are no questions, right? So we have covered everything, right? So we built the container, we looked at CVEs updates, we talked about concourse, we talked about embedded OS, and then we talked about 3Rs. I will talk about NSXT tomorrow. So this is what the platform does. I mean, literally, right? Like in 15 seconds, I was able to push an application, and I could actually build a production-ready enterprise-grade Restful web services in less than 10 minutes. So you can imagine how powerful that is. There is a Forrester study that I will share after this session. So they have looked at 4 different verticals, right? So the return on investment of using Pivotal Cloud Foundry was 135%. I will share that study later. And then everything we do at Pivotal, right? So we believe that, like, modern applications, I mean, you should strive for these 5 S's. So that is speed, stability, scalability, security, and savings. And through my demo, you have seen that how easy was it to push an application, right? And develop and push an application. We talked about blue-green deployments. We talked about concourse pipelines, right? And then we also talked about stability, right? So whether it is 4 levels of HA, or multi-tenancy, and so on and so forth. And scalability, right? You could one click to scale your applications up or down. And then the security itself, right? So we talked about that out of the box, the platform provides this IPsec add-on for network security. We support SAML authentication and OAuth authorization. And then we also talked about 3 Rs, repair, repave, and rotate. And then, I mean, you can imagine the developer productivity, right? So a few clicks, I could push my application, and the same thing from an operator's point of view, right? So typically, the operator to developer ratio is the developer to operator ratio is 500 developers to one operator supporting the platform. And the reason behind that is that everything is automated, right? So very powerful. So a few things, right? So I mean, software is what differentiates you in the marketplace right now. I took this Twitter feeds from the last 2 months, as you can see from the retail, right? So Kruger and Home Depot. So Kruger online sales have gone up by 66%. They started using TCF. Amazing, right? So again, the same thing with Home Depot. That's retail, and then if you look at telecommunications, right? T-Mobile, Comcast. We have other success stories such as Boeing, T-Mobile, and Liberty Mutual. I'm just glancing over them. But again, leading companies, they trust Pivotal, right? So 7 of the largest banks, 9 of the largest telcos, and so on, they all use Pivotal Cloud Foundry. So one other thing, right? So Pivotal is a platinum sponsor to the Cloud Foundry Foundation itself, and it invests heavily in open source software. So whether it is Spring or Cloud Foundry or Concourse, Bosch, RabbitMQ, Greenplum, and so on. The ecosystem is an ever-increasing ecosystem that supports the platform itself, depending on which vertical or product set you're looking at, right? So whether it is analytics or CI/CD or database and so on. So I started my session with the mission statement, right? So how do you transform? Our mission statement is transform how the world builds software. And as you have seen, right, so through the process and culture, as well as through tools and the platform, we provide you the everything, the secret sauce that you need to succeed, right? So that's all I have. Any questions?